Now that I've shown you how to design both series and parallel stubs, let's talk about what we can do to make the stubs the shortest possible length, or to make stubs inductive or capacitive. Let's start with our series case. In the series case again, we're going to design a stub which could be open-circuited or short-circuited on the end, that's going to help us match our load to our characteristic impedance. This A point right here is found by rotating a distance d until we get to the matching circle, and the length of the stub is found by removing the imaginary part that we have at ZA. So let's just suppose that my ZL happens to be right here as it was before. The first thing that I'm going to do is rotate a distance d to the matching circle, and I'm going to be going towards the generator, So here's ZL, and I'm going to rotate this distance d to ZA. So d is found by rotating that distance. The other possible place that I could have had was to keep going until I came back around this way, and here is another possible ZA2. Let's say that I have an open-circuited stub. Which of those would give me the shortest length of stub? Here is Z of an open circuit. Well, if I used ZA1, I would read off this value for X, and up here would be Z of the stub for my first case. If I did it here, I would read off this value, and Z for my stub would be here for my second case. These are supposed to be conjugates, and if I'd measured my distances a little more carefully, they would have been. So Z1 and Z2 are both possible stubs for an open-circuited load. Now let's consider, right there's my Z stub. I'm going to go towards the load to get to my open circuit. This is the towards the load case. Right here, my Z stub 2 going towards the load is going to have the shortest length. Z stub 1 would have been a much longer path. So if I wanted to find the shortest stub, I really am going to have to draw both of my possible choices on the matching circle, and then I'm going to have to evaluate each of those possible choices given the load that I have on the stub to see which of those two stubs are the shortest distance. Let's suppose that instead of that, I had been told I wanted the shortest D, which would have defined that I was using ZA1 and consequently Z stub 1, and been asked if it should be short-circuited or open-circuited to have the shortest length of stub. Well, again, what I would do is I'd start out from my stub, and I would rotate until I got to either a short or an open, and right here is Z of a short circuit, so my shortest length of stub and my shortest distance would occur when I had a short circuit. Now let's ask one other question. Which of these two stubs, 1 or 2, is inductive and which is capacitive? In the case of Z for inductors are above this line, so this one is inductive, and Z of capacitors is below this line, so this one is capacitive. Now let's talk about how this would change if instead of having a series stub, I had a parallel stub. Well, the first thing is that I would have converted ZL to YL, and I would have done all of my design that way. Remember that Y of a short circuit, Y of an open circuit is here, and Y of a short circuit is there. Remember one other piece here, that Y of a capacitor is here, and Y of an inductor is there. So I would do this design exactly the same way. I would analyze my distance and the length of the stub the same way that I did for the series case. I would also analyze my loads, the open or the short, the same way, except that they're going to be in different locations. So those are the things that would change if I were looking at a parallel stub instead of a series stub.